When you think of cutting-edge science, what comes to mind? For a lot of us, it's probably these gigantic machines, some of the largest things humans have ever built, all designed to explore the deepest secrets of the universe.
Well, today we're diving into a really cool conversation from Under the Microscope, the flagship podcast from the Science Talk. They had senior scientist Jens Osterhoff on, and he talked about a technology that is about to turn this idea of big science completely on its head.
So, let's get right to it. What's the issue with our current approach? Well, it all comes down to sheer, massive scale.
Just think about CERN's Large Hadron Collider. It is an absolute marvel of engineering, but it's built inside a 27-kilometer ring deep underground. We're literally talking about city-sized science here.
And you can imagine, a machine that big comes with some equally big problems. You've got huge infrastructure, absolutely massive cost to build and maintain it, and it's only accessible to a very, very small number of researchers in the world.
But here's the thing, a revolution is underway, and it's one that promises to radically shrink these scientific giants.
I mean, what if you could take the raw power of that 27-kilometer ring and squeeze it down into a space, well, about this big?
This is where it gets wild. As Jens Osterhoff explains, we can now get similar particle acceleration in just 3 centimeters. And note, that's not a typo. We are going from kilometers down to the length of your thumb. It's incredible.
So how on earth is that even possible? The tech is called laser plasma acceleration. Basically, scientists fire an unbelievably powerful laser into a plasma, creating this kind of wave. And electrons can then essentially surf this plasma wave, getting accelerated to insane speeds over a super short distance. Okay, so this is really cool science, for sure. But what does it actually mean for us in the real world? Because this isn't just about building smaller labs, it's about changing lives. Osterhoff makes this fantastic comparison. He says it's like the leap from the old room-sized supercomputers from back in the 70s to the unbelievable portable power of the smartphone in your pocket right now. When you make technology that compact and that affordable, you don't just improve it, you unlock entirely new possibilities you never even thought of.
And the potential applications here are just astounding. Think about mobile cancer therapy units on the back of a truck reaching remote areas, or powerful X-ray lasers that can fit on a tabletop in a university lab, maybe even tiny endoscopic tools that could perform therapy right inside a patient.
This shift from the massive to the miniature is really set to redefine what's possible in science, in medicine, and honestly, probably way beyond. And like Osterhoff said, the real key here is mobility. The moment these powerful tools are no longer stationary, their potential to help society becomes almost limitless. So it leaves us with this really fascinating question to think about. As these universe-shrinking machines become pocket-sized, what new worlds will they let us discover next?